especially with analog instruments such as those found in.
These are the classes for signal processing, divided into time domain and frequency domain wave classes. They are universal and can be used in all application domains like analog, mixed signal, DC, RF and jitter test. All of these classes are thread-safe and multi-site aware. DSP, or digital signal processing classes, are typically time domain and frequency domain based. In addition, there are also DSP classes for handling other tasks in testing. This module focuses on the classes multi-site wave, multi-site spectrum and single-site handling. Click on the class with the interaction markers to explore them further. Once you're done, you can continue to the examples and quizzes. Multi-site wave double and multi-site wave long classes contain waveforms of all sites as double or long type arrays. They also contain properties of the waveform like sample rate, digitizer termination, and methods to access, process and display the data. Click on the interaction icons to explore every element. Multi-site wave classes contain many properties of the signal. These properties can be accessed through the use of getters as shown in the example code. Calling the method getWaveForm on a result handler returns the captured waveform in a multi-site wave double or multi-site wave long object. Multi-site wave classes have many methods available which can perform math and other functions on their contents. This reduces the burden of the user having to write code. Check out the resource section for a complete list. The most common use for multi-site wave classes is handling of analog or RF captured signals. The data contained within them can be exported to different file formats that allow you to analyze them using external software. Importing data into the classes is also available. This allows you, for example, to populate a class with simulated data. The multi-site spectrum class contains the magnitude spectrum data of all sites. It also contains the properties of the measurement, waveform or spectrum and methods to access, process and display the data. Click on the interaction icons to explore every element. The multi-site spectrum class has numerous properties that it can contain. Setters can be used to populate or modify the properties, and getters can be used to query them. Typically, multi-site spectrum objects are created by calling the method.spectrum on a wave object. The unit of the spectrum can be selected with the spectrum unit parameter. Multi-site spectrum classes have many methods available, which can perform math and other functions on their contents. This reduces the burden of the user having to write code. In this code example, the multi-site spectrum object spectrum is created when the spectrum function is performed on the multi-site complex object wave. Click on the highlighted keyword spectrum and press Ctrl+Space to open Content Assist and get an explanation of the spectrum function. These are the units that are available with a multi-site spectrum object. The multi-site spectrum complex class contains the complex spectra of the waveforms of all sites as complex arrays, along with properties of the spectra. It is used for complex data processing in the frequency domain. Usually objects are created by calling the method FFT on a wave object, as you can see in the code snippet on the right. Hover over the expand button to see the complete code. This class is used in applications where the phase information is relevant. For the computation of the common figures of merit, such as THD and SNR, multi-site spectrum should be used. While this module contains detailed information about multi-site classes, note that there are options available for single site, which will be explained now. Single site classes like Wave Double or Spectrum are available to process the data of a single site. These classes usually have the same structure and member functions as the multi-site classes. The code snippet shows how a new object of type Wave Double is generated and then loaded with single site data. Hover over the blue Expand button to see the complete code. All multi-site classes are site transparent, that is, all sites are treated in the same way. To process each site individually, for example for servo loops or value-based per site branching, use site loops and the dedicated classes for single site handling. Java operators can be used in case the single site methods return primitive data types. The code snippets on the right shows an application of single site processing where it is used to perform a peak search to compare test data in different bins. Hover over the blue Expand button to see the complete code. If you want to explore different methods to perform a peak search, click the Interaction button. The code examples on this slide show two different methods for performing a peak search. The first approach finds the peak and peak index over the entire captured spectrum. The second approach first reduces the captured spectrum using the extract values function and then does the peak search over the smaller portion of the capture. Note that in both of these examples, the code can be simplified by eliminating the declaration of mySpectrum and using the primitive wave.spectrum in the calculations of max value and max index. Let's take a look at a complete example using a measurement performed on a WaveScaleMX digitizer. Click on the arrows of the yellow stickers to advance to the next step. The multi-site Wave Double and multi-site Spectrum classes contain all sites data. The methods process all sites data by one method call. Multi-site Wave classes contain waveform data, properties, and various DSP functions for all sites. Here, the spectrum of the waveform data is calculated by the Spectrum method of the multi-site Wave Double object. The Spectrum method outputs a multi-site Spectrum instance which keeps the properties of the original multi-site Wave Double object. The plot method outputs the graph of the spectrum data. Properties are used to calculate information such as resolution bandwidth to show the scale of the graph. These are the key things to remember from this module.